Hello everyone and welcome to the Invention Studio YouTube channel. In this video, we're going to be going over the prospective PI training for the Waterjet. The first thing that we would like to do is make sure that you do not just watch this video and begin using our Waterjet, as this video is not a way to get authorized to use our machine. You must still go through the training and testing process like every other user. Before we start this video, one thing that we like to make note of is that we want to be as safe as possible whenever we are using the Waterjet. To do that, what we want to do is make sure we are wearing safety glasses. You can grab some before you enter the metal room and make sure that you are always wearing them whenever you are inside of the metal room, especially when you're using the Waterjet. Also, you want to make sure that you are wearing closed-toed shoes to prevent any injuries to your feet. And finally, what you want to do is make sure that you do not have any cuts on your hand, because the Waterjet, the water inside of it, is filled with a lot of bacteria. And if you have any cuts on your hand, that bacteria will be able to find its way into your system. Finally, when the Waterjet is actually running, what you do never want to do is put your hand into the Waterjet, because the water that is coming out of there will be very easily able to cut through your hand, and you don't want that to happen. If you notice anything going wrong with the machine, always pause it before you put your hand inside of it. And also watch out for sharp metal parts, especially the slats inside of the Waterjet bed, as those are being cut while we are running the machine, and they will have usually pointy ends that you can easily cut yourself with when you are using the machine. With that said, let's begin this training by establishing a high-level overview of what the Waterjet machine actually is. So to my right is our CNC Waterjet. CNC is an acronym which stands for Computer Numerically Controlled, meaning a computer is going to use some numbers to control a device. The device in this case scenario is our Waterjet. The Waterjet uses a stream of highly pressurized water to cut through a given material. In reality though, the water itself is not doing most of the cutting work. What is doing most of the cutting work is this red material known as garnet. Garnet is an abrasive material, and it is being mixed into the water stream and accelerated to the same velocity that the water is moving at, and it is actually doing most of the cutting work. We are effectively sanding your part down very, very quickly whenever we are using the Waterjet. With that high-level overview established, let's go ahead and begin this training. The first thing that we want to do is make sure we are signed into the Waterjet on SUMS. Simply tap your buzz card on our SUMS computer, and then scroll down until you see the Waterjet Large, which is our red Waterjet, and hit login. Now let's turn the machine on via our 6-step startup process. All these steps are labeled, and it is important that you go in the correct order to avoid damaging the machine. Step number 1 is going to be against this back wall, and it is going to be labeled, of course, and it is going to be turning this blue handle parallel, and that's going to allow water to start flowing into our machine. Step number 2 is going to be adjacent to it, and it's turning this green handle parallel to allow compressed air to start flowing to our machine. Step number 3 is going to be turning on our large garnet hopper. To do so, all you have to do is pull this handle up, and once it's pulled up, it will create a air pressure inside of this chamber, which will force garnet from this larger hopper into the smaller hopper located on our actual Waterjet. If this handle is already up, you do not have to do anything to it. You can move on to step number 4. Step number 4 is going to be turning on part of our pump. To do so, we're going to reach down here, and there is a breaker labeled step number 4, and we're going to rotate that parallel, and that's going to send power to our charge pump, part of our entire pump assembly. Step number 5 is going to be adjacent to it, and it's going to be turning this breaker, so it's pointing up to the ceiling, and that's going to send power to the actual high pressure pump, as well as the VFD controller for our pump. Finally, step number 6 is going to be right over here next to the Waterjet. There's going to be another breaker. Turning that parallel will allow us to send power to the monitor connected to our Waterjet computer, and also send power to all of the motors attached to our Waterjet in the X, Y, and Z directions. While we wait for our computer to boot up, one thing that we want to check for is on step number 5, we want to come and look at this orange screen and make sure that we do not have a pump fault. 9 times out of 10, you are going to experience a pump fault. To get rid of that, all you want to do is hit the reset button located in the bottom right, and you should see that pump fault is gone, and now we can read the RPM that our pump is spinning at. If you do not see that it has been cleared, reach out to a Waterjet master. Now that our Waterjet has been turned on, we can go ahead and start preparing our DXF file. Your DXF file is going to be located in the checklist files folder located on the desktop. Open it up, and you're going to see an Invention Studio _Waterjet checklist.dxf. Again, DXF file is the only acceptable file type for our Waterjet. So whenever a user walks in and asks, can you cut something on the Waterjet for me? Ask them, do you have a DXF file for me? We're going to left click that and open it up in Omax Layout, the first software that we'll be using. This software is going to be the numbers portion of the CNC process, and we are going to effectively generate all of the numbers that the computer will eventually use to control the machine. Once our DXF file is open, the first thing we want to do is make sure that we are operating in the correct unit. Up top here in the software, we can see that units are set to inches, and that is the correct standard that we will be using for this machine. Make sure that you are operating in the correct units that you want to use, because DXF files do not preserve units. So if someone catted something in millimeters and said it was about 100 millimeters wide, this machine would think it's 100 inches wide. A way you can check that is by going to the size option and seeing the size, which is the width and height of your part. And make sure, again, that these values are in inches, and you can confirm these values with the user. So I could ask my user, hey, is your part about 7.6 inches wide and 5 inches tall? If they say yes, it is, I can go ahead and start doing the cleaning process. Once we have ensured that our part is of the correct size, we can go ahead and begin cleaning our part, which is getting rid of any irregularities that the software sees in our file. To do so, we can head over to the right-hand side and hit the clean button. Don't worry about any of these values, just make sure that all of these checkboxes are checked, and you can go ahead and hit start. You can see that our part has started with 305 entities and has been reduced to only 280 entities. 25 have been removed, which you can see were unnecessary dots that the software was able to identify. Also, the software did close 60 gaps for us, which is nice. Any of these irregularities could have caused the machine to experience a failure when it was actually cutting our part. After cleaning, what we want to do is actually keep cleaning again. So hit the clean operation and hit start once more. And what you want to do is keep cleaning your file until you eventually see all zeros across this column. Once you see all zeros, that's the software telling you as a user that the software does not see any issues with your file, and you can go ahead and begin proceeding with the rest of the setup process. We hit OK. After cleaning, what we want to do is assign a quality to our part. To do so, come down here and right-click quality, and then make sure that you select all, because we want to assign a quality to our entire part, not just a portion of it. And once you do that, it's going to give you a pop-up menu, and it'll allow you to choose between 1 through 5. A higher quality number represents a better surface finish on our part, but it also means that the part is going to take longer to manufacture and therefore use more garnet / cost more money. Whereas a lower quality will make our part a bit rougher, but will make our part in a much shorter amount of time. Usually for us, we stick to a quality of 3, as we find that to be a good middle ground between a fast part and a relatively good, well-surface finish on our part. Once we hit quality 3, you'll see all of our green lines have turned to magenta, indicating to us that we have selected a quality for our part. After doing so, we can go ahead and generate the path that the machine will actually take when it is cutting out our part. To do so, go to this left-hand side and hit auto path with the left click, and it's going to draw a couple lines in the software. So these green lines are known as traversal lines, which is where the Waterjet is simply moving from point A to point B, and it is not doing any cutting in that motion. These orange lines / yellow lines are called lead in and lead out lines. Right here, the Waterjet is going to begin firing and cutting through our material, but it is not actually manufacturing our part, which you can see in magenta. It is simply making its initial pierce and then walking itself in to start cutting out our part. And then the magenta lines, of course, are where your actual part will be manufactured. So for us, we just left click this auto path and made a quick outline of the path that we want to take. But if you want to go into a more advanced feature, you can right click it and go to auto path, advanced and configure. And this will allow you to effectively choose your starting and stopping points on the Waterjet. For us, we are usually going to start in the bottom left-hand side of the Waterjet and end in the top right, meaning that we are going to move in the positive X and positive Y directions. To do that, we're going to hit the green arrow on the bottom left-hand side to indicate that we want to start down in the bottom left, and we are going to hit the red icon in the top right to indicate that we want our part to stop in the top right corner. Once we do that, we can hit go. Do not worry about any of these parameters down here. That's outside of the scope of this video. After generating the path the machine will take, the next thing we want to do is add tabs to our parts. Tabs, in a machining sense, are little pieces of material that keep our part attached to our overall piece of stock to prevent it from falling apart, or potentially for the Waterjet, rising up due to buoyancy effects and colliding with the machine as it is cutting. To add a tab, the manual method is to come over here and right-click Lead I/O, and you will see the Create Tab option. If you left-click that and bring your cursor over, you will be allowed to place a tab on your parts. When placing a tab, what we want to do is make sure we place our tab in an accessible location. So right here on this inside portion of our larger piece, I probably would not want to place a tab right there because it's going to be harder for me to remove that tab later on once I get my part out of the machine. So instead, I'm going to place my tab up top on that easy to reach section. We want to make sure that we add tabs to both of our parts. So for this GT, the smaller part, we want to add another tab. And also we don't want to add a tab to this curved portion because once we remove that tab, that curve will most likely have an inaccurate geometry. And therefore we want to make sure that we place our tab on a relatively flat portion such that when we remove it, we do not affect the dimensional accuracy of our part. After adding tabs, we can go ahead and click Post, right-click it, and hit Automatically Generate. And you're going to see a screen that asks you to select your starting point for where you want the machine to actually start the cut. For us, we've defined our point as the bottom left corner, so we would click that. However, for this, I'm going to actually hit the top right section, which we've defined as our endpoint. You'll see that it will still accept this point, and it will draw the actual route that the machine is going to take when it is cutting. And if we zoom in, these black lines are where the center of our nozzle is actually going to be moving. And we'd like to imagine that the water coming out of our nozzle is a line with 0 dimension. In reality, it is more like a cylinder of water that has a certain radius associated to it. That radius is going to be 0.021 inches or 21 thou, meaning that the diameter of our nozzle is about 42 thousandths of an inch. And what we want to do is actually offset our machine by that amount to make sure that we retain dimensional accuracy of our parts. If you've ever done woodworking or used a blade in general, this is exactly the same as accounting for the thickness of your blade whenever you are manufacturing a part. For this, you can see that our nozzle is currently being offset on the inside for these outside perimeters and on the outside for these inside perimeters, meaning that this overall piece is going to be a bit smaller than it should be, whereas these interior pieces, such as the GT logo, are going to be a bit larger than they should be, which is incorrect. Yeah, and that's on purpose because we clicked the incorrect starting point. But I just wanted to show you guys what it would look like if you got an incorrect file. If this happens to you, all you want to do is hit reject and go back to post and hit automatically generate again. And this time I'm going to click the correct starting point, which is my bottom left. Once I do that, if I zoom in, you can see that now the machine is traversing on the outside for those outside perimeters and on the inside for those inside perimeters, meaning that our part is going to be dimensionally accurate when it is manufactured on the Waterjet, because now the Waterjet is properly accounting for the radius of the water. Once we realize that our path is set up properly, we can hit save. And that is going to be the last step that we do in the Omax layout. Effectively now, we've generated all of our numbers and we can begin using those numbers to actually control the machine. To export this file, right-click Post once more and hit Open ORD Path in Make. While we wait for Omax Make to load up, we can go ahead and go to the right-hand side of the Waterjet and grab our testing material. These are going to be 2 foot by 4 foot aluminum sheets, and you can usually see that people have already manufactured instances of the testing part on these pieces. We can lay our testing material down and go back to our computer. Once we go back to our computer, the first screen that we are going to see in Omax Make is a material template setup. And make sure that these checkboxes for your test are unchecked, these low pressure settings. We are not going to be using low pressure for our test. And the two things that we want to edit are the material that we will be using and the thickness of our material. For the test, your material is going to be aluminum 6061. If you scroll into the metal section, aluminum will be one of the first options. Again, make sure that you hit aluminum 6061. By selecting that material, we are effectively telling the machinability of our material. A higher machinability score means that a material is easier to cut through. So if we compare the value of steel, it has a value of around 80 compared to aluminum, which has a value of 219, meaning that aluminum is easier to machine, which if you've ever used aluminum versus steel, you would know that. One thing that you will be asked during your Waterjet training, or testing, is what kind of materials can the Waterjet cut through? The correct answer is technically everything, and if you say that, you will pass. However, the better question that we're actually trying to ask is why can the Waterjet cut through everything? The reason for that comes in 2 parts. For one, the Waterjet is using water as its cutting medium, meaning that it will never produce any toxic byproducts when it is cutting through a material, which is unlike some other machines, such as our laser cutter, which heat up your material to cut through it. So for certain materials like polycarbonate or foam, when you heat those materials up, they will release toxic gases, which are bad for us to inhale. The Waterjet, however, you'll never have to worry about that because water and garnet are usually non-reactive with any material, and therefore you don't have to worry about it creating any nasty byproducts. Another reason that the Waterjet can cut through effectively anything is because for this larger Waterjet, we can operate in both high pressure and low pressure, where in high pressure, we have enough velocity in our water to cut through very thick pieces of material, including 6-inch thick steel, whereas in low pressure, we can cut more brittle materials such as glass or acrylic, without having to worry about exploding those materials when the Waterjet pierces through them, just because it is using that low pressure and is slowly cutting through the material. So again, what materials can the Waterjet cut through? You can technically say everything and pass, but a better explanation would be saying those 2 aspects. 1, the Waterjet is using water, which is non-reactive, and 2, the Waterjet can operate in both high pressure and low pressure, which allows it to cut brittle materials as well as very strong materials. After material selection, the next thing we want to do is indicate to the Waterjet what the thickness of our material is going to be. So if we grab our material and bring it over, we are going to have to use calipers to measure this, or if you know this value off the top of your head, you can just simply type it in. Calipers are going to be located in that drawer to my left, but I know that the thickness of this material is going to be about 0.08 inches, or 80 thou. Again, make sure that you are typing in all these values in inches, because any metric values the Waterjet will not be able to understand. So if someone walks in with a piece of material that is 3 millimeters thick, don't just type in 3, that will confuse the machine. Convert that value into inches before doing so. After setting our material and our thickness, we don't have to worry about any of these other parameters in the setup screen. Make sure, again, that these 3 checkboxes are unchecked. If that is all good, then you can hit OK. And the machine is going to start generating the actual path and the statistics for that path. One thing to note is if you ever realize that you've typed in a value incorrectly, or if you forgot to uncheck one of those checkboxes, to go back to that startup screen, you can just hit the Change Path Setup, and it'll bring up that initial menu once more. For us, though, we typed in everything correctly, so we are all good. One value to take note of is that once you load into Omax Make and have set up all your materials, you're going to see a value, which is your time per path. And the machine is telling us that this path is going to take us about 1.5 minutes to cut, effectively meaning that's going to take 90 seconds for our part to be manufactured once we start cutting it. This is a helpful value to know, just in case someone is behind you on the Waterjet and they ask you, hey, how long is your cut going to take? You can tell them it should be about 1.5 minutes. That does not include the setup time, of course, so you should also try and factor that in. Once we are in Omax Make, we can start controlling our actual Waterjet. Before doing so, however, we want to make sure that there are no faults. If there are, we want to clear them. To see if there are any faults, we can go into the bottom right-hand side of our Omax Make screen and see, hey, there's a fault, so we have to clear it. The way to clear a fault is coming over to the right-hand side on these buttons. First, you want to hit the green button, make sure the machine is actually turned on, and then to actually clear the fault, all you want to do is hit the black button, then the green button in rapid succession. You only have to click them once. You do not have to spam them multiple times. Doing it once is going to be enough. And you can see in this bottom right-hand corner, the fault has disappeared. And now if we take our keyboard and use the arrow keys, we can begin moving the machine around. And if we want to go faster, we can hit the shift option and then use the arrow keys again, and that will allow us to have rapid traversal features on the machine. And that's going to allow us to move the machine in the X, Y directions. If we want to move the machine in the Z axis, the fast method for that is going to be using 1 and 7 for up and down. And if those buttons don't work, make sure num lock is not engaged. And if we want to do more fine adjustments, we are going to use page down and page up. Once we are in the Waterjet control system, what we first want to do is lower the water level before we add our material in. The way we do that is by using this joystick, which is connected to our ballast tank. The ballast tank you can effectively imagine as a big balloon where the water is on top of that balloon and it is connected to our airline. If we add air to that balloon, it's going to expand and therefore cause our water level to rise. If we deflate that balloon by taking air out, however, it's going to cause our water level to lower. To do that, if we bring this joystick up, the water level will begin rising, and if we push this joystick down, the water level will begin lowering. One thing that can happen is sometimes you may push this joystick all the way down, and you will realize that the Waterjet or the water level has not lowered to a sufficient level, and that is because the Waterjet is continuously adding water as it is actually cutting, meaning that the lowest water level setting may actually be a bit too high for you. If that does ever happen, what you want to do is come to the right-hand side of the machine and to this corner, and there is going to be a little plunger right here that you want to rotate downwards and push it underneath the water, and that is going to allow water to be drained into this blue tank. This will effectively allow you to set the lowest water level in the Waterjet bed. Make sure, however, that you bring this plunger back up before you start cutting, as if you leave it down, it will continuously drain water, which is not good. Once the water level has been sufficiently lowered, we can go ahead and remove these acrylic guards. These acrylic guards, their official home is going to be on the slat. You can just slide them in and leave them like that. Sometimes also, you may find people leave them on top of the water pump, which is perfectly okay. What we do not want to do, however, is leave these acrylic guards on the floor. They are relatively see-through, and people may not realize that they're on the floor, and they may trip over them, which is a safety hazard, and they may also break them in the process. And these guards are relatively expensive, so please do not leave them on the floor. Make sure that they're either in one of these two locations. Once the acrylic guards have been removed, we can go ahead and load in our material. For us, we're going to be starting in the bottom left and moving to the top right. So I'll probably start in this corner right here, and I'll move to the top right and ending about here. One thing that you want to make sure is that you are not generating a lot of waste material. For these cuts, you can see these people did a relatively good job of starting close to the edge. This cut a little bit right here, that may be a bit too much, but this is a relatively good example of reducing waste material. A bad example of reducing waste material can be seen on this cut, where you can see that this user started his or her cut very far away from the edge of our material, creating a significant amount of waste material, which is not good because we want to make sure that we are getting the most out of our pieces of aluminum because it is not cheap. So knowing that I'm going to start in this bottom left-hand corner, I can load the material onto the vertical slats. Make sure that you do not poke yourself against these vertical slats. They are relatively sharp. Also, if you have any exposed cuts on your hand, make sure you put a bandage over them because the water inside of the Waterjet is full of a lot of bacteria, and you don't want your exposed cuts to be introduced to those bacteria. We can go ahead and slide our piece of aluminum against the edge of our rails. And then what we want to do is actually secure our aluminum to the Waterjet bed. The way we do that is by using these clamps located in the clamps box. We can grab 2 of them. Always make sure that you're using 2 clamps. 1 clamp by itself is never going to be enough because all that's doing is putting your part on a pivot point. You always want to make sure that you're using 2 clamps just to ensure that your material has no chance of moving. So for us, we know that we're going to be starting right here and moving to about right here during our cut process. So this is effectively the bounding box of our cut, and we want to clamp a little bit outside of that bounding box. Whenever you are clamping, it is a bit of an optimization process because you want to make sure that you clamp close enough to where your material is going to be cut out to make sure that the material does not vibrate or move in any way while it is being cut. But you don't want to clamp so close that the Waterjet actually collides with one of your clamps while it is cutting out your part. For clamping, we want to insert these D-shaped parts parallel to the rails and then rotate them 90 degrees such that they can no longer be pulled out. Once we have done that, we can rotate this black handle, and that will actually allow us to clamp our part down. And then I'm going to do that on the other side as well. Again, inserting it so that it is parallel. and then make sure that these cylindrical pieces line up, rotating it, and then spinning the black handle down to secure my material. You don't have to go super tight with clamping, just make sure that if you take your fingers and try and move your piece, it should not move whatsoever. If you experience any play inside of your piece, you have to reconfigure your clamps because you're going to result with an inaccurate part once you actually cut it if your material can vibrate or move. Once the piece has been clamped down, what we want to do is grab our keyboard and bring it over. Don't worry, this keyboard is relatively water resistant. Don't dunk it in the water, obviously, but don't worry if any water splashes onto it. And we're going to take our Waterjet, and if the yellow plunger was not already up, you would want to flip it up to expose the nozzle. And you want to bring the Waterjet closer to you, again using the arrow keys to move in the X, Y directions, and using the shift option to move more rapidly, and then using the 1 and 7 options to move rapidly in the Z direction. And then we're going to grab a feeler gauge located in our clamp box. It is a relatively thin sheet of aluminum, which has a very specific thickness associated with it. We're going to lay that feeler gauge underneath the nozzle and approach it. And we can approach using the 1 and 7 buttons, so we can move relatively quickly. And then once we're relatively close, we can start using the page down and page up options. And while we are doing that, we can start swiping our feeler gauge underneath the nozzle. And then eventually what you want to feel is that your feeler gauge barely grazes against the nozzle. And that will allow you to know that you are at the proper Z-axis offset. Once we have the correct Z-axis offset set by using our feeler gauge, we can come back to our computer and make sure that you hit this 0 Z1 counter. Do not hit the arrow, which will tell the machine to go to Z equals 0. It will ask you, are you sure that you want to 0 the Z1 counter? We hit OK, and now we see that the machine is set to 0 for its Z-axis position, which we have just set using our feeler gauge. The next thing that we want to set is our X and Y home. To do that, we know that we are going to be starting in this corner, so we want to slowly move the machine over to that area. Again, you can use the shift button to move relatively quickly. Once you start getting close to one of these rails, however, go a bit more slowly just to make sure that you do not collide the nozzle with any of the rails. And one thing to note, again, because we are trying to reduce waste material, we want to get as close to the rails as possible. Do not worry about this plunger being deformed. It is made out of rubber. It is meant to deform. It will snap right back into place once the machine moves away from one of the rails. And as long as you do not actually make contact with the rail with the nozzle, and you set your X and Y home properly, you'll never have to worry about the nozzle making contact with one of the rails because these motors are relatively accurate. So that is going to be what I consider a good positioning for my X and Y home. It may be a bit hard for you to see in the video, but I'm about 1/4 of an inch away from the bottom and left-hand side of my piece of aluminum. Once I have that, I can go back to my computer and hit 0 on my path start point, which is going to be 0 in my X and Y. It'll ask me, are you sure? I will hit yes. And I also want to go ahead and 0 my user home. And that is going to allow me to set the origin of where I'm going to be starting my cut. Two things to note is why do we actually do this? For one, the Z-axis, we want to make sure that we have zeroed it properly, because if the nozzle is too close to our material when it is cutting, it may be able to collide with our material as it cuts, because our material may have a bow in it, so it may be zeroed at a low point, and when it gets to a high point, it may collide, especially if it is too close. And also if the nozzle is too far away from our material, if it was too high, when it actually is firing water, you can imagine the water, instead of a cylinder of water, you can imagine it as a cone, which is increasing in radius as it gets farther and farther away. So if the machine was farther away, that radius that we initially set as 0.021 would actually increase in size and therefore result in a geometrically inaccurate part. So we want to make sure that our Z-axis is set just right to make sure that we A, don't collide with our material as we are cutting, and B, that we don't create an inaccurate part. Once we have our X and Y home set correctly, one thing that you have to show to the PI who's administering your test is how to go to a spot on your path and how to check if your path is not going to collide with any of the clamps that you have positioned. To do that, what you want to do is right-click Begin Machining, and you're going to see an option, Go to Spot on Path. Left-click that, and bring your cursor over here, and you're going to see a crosshair, and you can click any point on your path, and the machine will take a direct line to that position. So for us, we know that our clamps are in these bottom right and top left corners, so we want to check, am I going to collide in either of these two areas? However, what we don't want to do is go directly to one of those areas, because if we realize that we are going to collide, it's just going to make the machine collide with that clamp immediately. What we instead want to do is go to an area that we know is going to be safe, and then slowly creep up on where we think our clamp is going to be, and check, hey, am I going to collide with this clamp? So I know that in this top right corner, there is no chance that the clamp is going to be there, so I'm going to click that. The machine will ask me, So for us, because we have turned the machine on, actually the first thing the machine will do is ask us to home the tilt axes. You can go ahead and hit yes on this, and it's going to start homing the tilt axes. Our Waterjet does not actually have any tilt axes, so it's not going to do any actual movements. If we had a 5-axis cutting head, it would be doing movements. But right now, for our basic cutting head, we don't have to worry about anything. Just hit yes, it'll start doing something. It's not actually going to move again, so don't worry about moving the machine out of the way. Just hit yes, and it will go through that homing process. And this is what you will have to do every time you turn on the machine for the first time. After the tilt axes are homed, it will ask us, are we ready to move the machine? And you can hit OK, making sure that there is nothing in the path of the machine that it's going to collide with as it is moving. Machine has moved, and if we come back to our computer, we can actually see that we have a pop-up menu where we have backup, continue, and ahead. And using the ahead and backup options, we can left-click those and slowly start going through our path. And if we look on our Waterjet, we can see that currently we're on the rightmost point in our cut file, but our clamp is actually located beyond that point. So our clamp is in a good position and is not going to collide with our part. And we know that because we are currently at the rightmost edge of our part. Now we have to check and make sure that our other clamp is not going to collide either. So we can hit close out of this menu, right-click begin machining again, and hit go to spot on path. And this time we're going to check for this top left clamp. Again, we don't want to move directly to that point as we may collide with it. So we want to go to a point that we know is relatively safe, such as right here. Hit OK, again, making sure that there's nothing in the path of the machine as it traverses to that location. And then I believe using the backup feature, we can slowly start creeping up to that top left area. And now that we're in that top left area, we can go back and check on our material. And we see that our clamp is well beyond that area. So we know we are not going to collide with this clamp either. Finally, one last thing that I like to do is hit close and then right-click begin machining and go to spot on path once more and go to this top right area of my part. And that is effectively going to allow me to figure out the bounding box of my entire part. So for this cut, because the machine I know is in the topmost and rightmost position right now, if I draw 2 lines coming from that area, I know that this is effectively the bounding box of where my part is going to be cut. And what I want to do is actually add a weight to that area or beyond that area. And weights are going to be located on this cart on the right-hand side of the Waterjet. And I'll take one of these and simply put it outside of that bounding box. Right here, a clamp could obviously not reach because we do not have clamps that are about 18 inches long, so we have to resort to using a weight. It is not strictly necessary, but it never hurts. One thing to note is that weights are not substitutes for clamps, because if I try and move this clamp with my hand, you can see that it's not going to move whatsoever, whereas this weight, I can move it relatively easy with my hand, meaning that the amount of clamping force that weight is generating is nowhere near the amount of clamping force these actual clamps are generating. So whenever possible, use clamps, but if it is impossible, such as for this top right area, feel free to use weights. And again, we can check and make sure our part is not going to move whatsoever, so we know our material is relatively secure, and we know that we're not going to collide with any of these clamps or weights when we are actually cutting. So we can hit close, and now we are ready to start cutting. One thing to make sure of is that before you start cutting, you want to make sure that your path start is set to 0, 0. Currently it is not. And even though we have set the 0, 0 point, if we actually left click begin machining, it's going to say path start is not at 0, continue anyway. If we hit OK, what the machine would actually do is interpret the current position of the Waterjet as the new path start point, and not the actual path start point that we have configured when we 0-0'd our X and Y axes. So we want to hit cancel because we don't want to consider our current point as the 0, 0. And instead, what we want to do is hit the go home button. And it's going to ask us, do you want to go home? And we make sure there's nothing in the way of our machine from going home, such as a weight or a clamp, and we hit OK. And the machine will traverse back to the 0, 0 point that we initially set up. Again, make sure that you are at the 0, 0 point before you actually start doing your cut. If you are not, the machine will interpret whatever you are, the position you are currently at, as the new 0, 0 point, and it will start cutting from there, which can easily lead you to colliding with one of the clamps or weights you set up on your piece of material. Now that we're back at home, what we can do is go ahead and flip this plunger down. Again, do not worry if it deforms a little bit, it will snap right back into place once it moves away from one of these rails. And we want to put our acrylic guards back into place. This larger guard goes on this left-hand side of the machine, and this smaller guard goes on the bottom side of the machine. Finally, what we want to do is raise the water level using our joystick, which is connected to our ballast tank. By raising the water level, we effectively are going to submerge our entire machine in water, which will allow us to reduce the noise that the machine is creating when it is actually firing. Because when the machine is running, the water and garnet that is coming out of that nozzle is moving about 4 to 5 times faster than the speed of sound, and we don't want to subject everyone in the metal room to sonic booms. By submerging it underwater, it will dampen out a lot of that noise. As you can see, this plunger is now completely submersed underwater, and we know that we're not going to be creating a lot of noise when we are actually cutting. Again, make sure that that plunger in the back right corner has been lifted up such that we are not continuously draining water as we cut. So now that our X, Y, and Z axes have been honed properly and we are at our home position, our acrylic guards are back up, our plunger is down, and our water level is raised, we can go ahead and begin machining our part. One thing to note is that even though we are 99% confident that this part is going to turn out well, what we do not want to do is start machining and then walk away from the machine and go do something else. Because again, even though we're fairly confident that this part is going to turn out perfectly fine, we want to make sure that we are next to the machine ready to stop it in case we notice anything bad happening. So the way to stop it is by hitting this red e-stop button located on the right hand side, or once we are in the actual begin machining option, we can hit this pause button to bring the machine to a stop. Or we can also actually hit the space bar. Try not to use the space bar, as sometimes that may be configured to a different operation in Omax Make. Ideally, just use the pause button or the emergency stop located on the right hand side. Again, to actually begin machining, what we want to do is left click begin machining now. Do not right click it. And then we can left click start. Before we actually do that, one thing that you can do as a last sanity check is do a dry run of your cut. And that is going to allow you to do one last sanity check and make sure that the machine is not going to collide with anything as it is actually cutting. The way we do a dry run is right clicking our start. Do not left click it. If you left click it, it will start cutting. If we right click it, it will bring up a pop-up menu and it will give us options to dry run at various speeds. We can go ahead and dry run at a full speed. And now the machine is going to start traversing around and going through the entire cut process without actually doing any of the cutting work. And while it is moving, we can watch it and make sure it's not going to collide with anything. And even though we checked the bounding box and we made sure that our clamps are far away, this is just a good way to check and make sure that there is no chance that the machine is going to run into any objects when it is actually cutting. While the machine completes its dry run, I will tell you the 3 things that you want to watch out for when the machine is actually running that may cause you to have to pause the machine during its cut operation is 1, you want to make sure that the pump is actually pressurizing the water. If the pump is not pressurizing the water, it will not be able to cut through your material. And usually the way to fix that is to clear the pump fault that you forgot to clear during your startup procedure. Another issue is that you may see that garnet is no longer flowing into the water jet. And if garnet is not flowing, if you are just firing water at your material, water by itself will not be able to cut. So you would have to pause the machine and fix that garnet clog. And finally, for certain parts, you may see that cuts start to rise up in the water as they're produced. And for this part, you can see that these GT logos are going to be cut out and they may drop into the bottom of the water jet or they may start floating up. If we see that they are floating around, we're going to have to pause the machine and grab those pieces and take them out just to make sure that they don't collide with the water jet as it is cutting. So now that our dry run has finished, we can hit the go home option once more. The machine will traverse back. Make sure our water level is raised. And we can hit begin machining, and then this time we can left click start and the machine will now start cutting. You will hear the pump start roaring up and you'll see the machine begin to start firing. Also, if you inspect this tube right here, you should be able to see that the garnet is flowing through that tube. If you don't see any garnet flowing, you will also be able to hear it because water by itself will just bounce off of your piece and start getting ejected to the side. But because we have good garnet flow, we know that this machine is cutting properly right now. Once the water jet has finished manufacturing our part, we can go ahead and hit 7 on the keyboard to raise the nozzle up and get it away from any objects that are potentially floating around. And then using the arrow keys, we can get the nozzle off of our actual material and we can see that the water jet was successful in cutting out our 2 parts. After the water jet has moved away, the next thing that we can do is use the joystick to lower the water level. Once the water level has been sufficiently lowered, we can go ahead and start unscrewing our clamps and taking them out of the rails. Make sure do not leave clamps on these rails, always return them to the clamps box, and also do not drop them into the water jet. If you ever experience that you are unable to remove a clamp, feel free to grab a paper towel. Your hand may be a bit wet, so it may be hard to get a good grip. And once it's loosened, go ahead and take it out. And then finally, we can go ahead and remove our weight, again, making sure that we do not leave it on any of these rails, always returning it to its location on the cart located on the right-hand side of the machine. This is our water line. We can take this and spray off all of the garnet that has collected on top of our work surface while the water jet was actually cutting. And also, because we want to be respectful to other users, we can try ahead and clean the actual rails on the water jet and get any garnet that is built up in these rails out. After we've gotten most of the garnet out, we can go ahead and start lifting up our material, making sure, again, do not cut yourself on these vertical slats as they are relatively sharp. And try and get as much water as you can off your material while the material is still inside of the water jet table. We can see that our tabs did a great job of holding our material in place and preventing them from falling into the water jet or colliding with the nozzle as the machine was running. To remove them, we can simply pull up and bend them out of place, and that tab has been removed. We can place our part down, make sure do not drop it, and we can grab our smaller part and rotate that out as well. Afterwards, we can take this piece of aluminum and take it out of the machine, and then walk it back over to the right-hand side where the other aluminum sheets are kept. Making sure that you don't poke yourself on any sharp points. Now that we have our two manufactured parts, the last thing we want to do is check how many hours have been clocked into the pump. The way we do that is by going into Omax Make and hitting history, and we want to go to the counters and timers option. This first value that you'll see, the total hours on pump, when you log out of sums will ask you how many hours are on the pump, and you just want to report this value. You can round it to the nearest integer. So for us, we have a value of 937.936, so we'll just round that to 938, and that is the value we'll type into sums when we log out of the machine. Before we sign out of sums, what we can do is turn off the machine. The way we do that is by going in the inverse order of how we turned it on. So instead of 1, 2, 3, 4, 5, 6, we want to do 6, 5, 4, 3, 2, 1. So for 6, turn this breaker so that it is perpendicular. That will cut power to the motors on the machine as well as the monitor. After that, breaker number 5 on step 5, turn that perpendicular as well. That will turn the pump off. And breaker number 4 down here, go ahead and turn that perpendicular as well. Coming over here, step number 3, we can actually leave because we don't have a way to actually turn this off. This handle will naturally fall down as this chamber depressurizes, so we can just leave this handle up. Coming over to step number 2, we can turn this green lever perpendicular to cut air from the machine. And finally, step number 1, we can turn this blue handle perpendicular to cut water from the machine. After doing that, the machine is completely turned off, and when a new user walks in, they will turn it on by themselves. Once you have turned off the machine, you can show the PI who has been administering your test your 2 final parts, and they will either check you off and pass you, or you will have failed if you messed up on any of the other procedures. Once you have been passed, make sure you keep these 2 parts as you will need them during your metal room testing. Thank you all for watching this video. We hope that it has been helpful for you, and we wish you the best of luck for your prospective PI checklist.